Hello guys, my name is Thubalami Nkomazana. So in my previous video we spoke about BLINKIT app, and in that video we're talking more about the ER diagram, how the entity relationship is, and the connection between the entities, their relationships and all that. So in this video we're going to be talking more about data structures. So in particular I'll be talking about the queue data structure, so implementation of the queue data structure in the same app, BLINKIT app. So we see that in the BLINKIT app, we use queue, and I'm going to be showing you how it is actually implemented. The BLINKIT app implements the queue data structure, or should I say the BLINKIT store in general implements the queue data structure in a way that processing of the order, it follows a certain principle. So the principle that is a FIFO, it is called FIFO in data structures. So what is FIFO? FIFO meaning first in, first out. So it means that whatever in our linked list, the first to be added to the linked list will be the first to be removed from the linked list. So how is this implemented in the BLINKIT app or in the BLINKIT store? We see that this is implemented in processing of the order and in orders that are made by customers. So take for example when a customer makes an order, so the first customer who made the order, their order will be the first to be processed, and their order will be the first to be scheduled the date of delivery. And also in terms of inquiries and in terms of queries, see that the one who places the query first or the inquiry first will be the one to be replied first or to be talked to first. Right. So we also see this in error handling, whereby a customer is complaining about a certain error that happened or a certain misconduct or something that happened. So that one will be the first to be replied to. So these are basically the applications of the queue data structure in the BLINKIT app. So without wasting much of the time, we shall see how we actually implement it in coding, how we actually code it out. So I'll be using VS Code for that. And also I'll be using Python for this type of question. So implementing queue data structure using Python in VS Code. So let's switch right into it and we begin to code. All right, guys. So first thing first, we are now at VS Code. So first thing first that we're going to do is we are going to create a class for the node. So let's begin to create a class for the node. Class. So that's creating a new node. So function to create a new node. So let's enter the function, define it. Right. So let's pass self. Data. Let's say data to be none. Right, data to be none, since we are creating at the beginning there will be none, so we are setting it to none at the beginning. All right, so let's define it. Self.data equals to data backspace self next is equals to none. All right, so the first data we've set it to none, so we have created our first node. Our node, this is for creating the node in the linked list for our queue this time. So now after this, what is next? So after this, we now have to create the class for queue, whereby we'll begin to name and define all the other things that will be there in the queue. So this one was for creating the node where we'll be adding the nodes and all that, adding the people to the queue. All right, so let's begin to create the class for queue. All right, so we define it. So let's define the terms. So we have front and we have rear. For the one who will be at the front and the one who will be at the rear as we continue to add them. So we name them self dot rear. Now let's start with front. Self dot front is equals to none. Self dot rear is equals to none. Right. So what else will be needed? Now we need to start adding the people to the queue. So next we create a function for enqueuing. Now we are adding the people function for enqueuing. So we'll call it enqueue. Enqueue, and then we pass self and we pass data. Okay, so now in this enqueue we'll begin to add, so we'll be adding new nodes. So this enqueue will be adding the new node, which is the person to making the orders, the order processing. Okay, so let's just call it a new node, right? And we name it to be equals to, so we'll call the class of node, so because we're creating a new node, so we'll call it here. So we'll call the function node in order for us to create the data, right? And then the data which will be inserted. All right, so now we have made that. Okay, so now we need conditioning. So say if self rear is none, right? So if self rear is none, self dot front will be equals to the new node, right? And then now equals to the new node, and then the self dot rear will also be equals to the new node. Self dot rear also equals to the new node. Right. So here we have defined the first clause, which is the if clause. So we're saying self dot rear is none. So if we're checking a condition, if self dot rear is none, that is we haven't inserted anything, then self dot front will be the new node. So meaning if there is no one in the who has placed the order, so whoever is placing the order at that moment will be the first one. So this is to explain this one, and then we made them to be self dot rear, which is the first one, right? So now let's focus on the else clause. That is to say, if the if statement is not true, else self dot rear, I just start dot next, which is the next person, is equals to new node, right? So we see that, so the next person will be the one who will be equal to the new node. So that's what we have done so far, created the in queue. So for placing the people in queue, we have created that one. Now let us move on to create another function. So we'll create another function, and this time we are creating a queue, meaning removal of the people, saying okay, this one has received their order, this one has done that. So that's the one that we're following. So say def create DQ self. Right. So now in dequeuing, we need conditions whereby we have also to check if it's the linked list is empty or it has someone already in the list so that we start saving them. Okay, so let's say if self dot front is none, we return none. So if self front is none, it returns none. Right, so create data. So we say data is equals to self dot front dot data. Right, that there. Now we say if self dot front is equals to self dot rear. Right, then self dot front equals to none. All right, so we've named there. Now we've created another if clause. After that one, we have retained that one. Then we said if self dot front is equals to rear, then return none. Now we have returned none for self dot front, then the self dot rear also will be none. Self dot rear is equals to none. Okay, so we've named those two, declare them none. Right, so what if they are not none? Else, so we create the else block. Else self dot front is equals to self dot front dot next. So that's for dequeuing. Self dot front will be equals to self dot front dot none. If we have checked that the front is none, then it will execute that one. Then if it is not none, then it will execute the else block. All right, so that's for dequeuing. Then else that, then let me shift there, and then self dot front is equals to self dot front dot next. All right, so now we have to return if it doesn't pass that. All right, we're done with the function for queuing. Now another function will be to check if it is empty, right? If it is empty, right? So def, call it is empty. Self return self dot front is none. Right, now we also know that we are able to look at another person behind the other person. Like if there is the person at the front who has given the order and there's another one behind them, we are also able to see them, right? Though we are most generally not able to access them, but we are able to see them. So create another function that will be pick. Okay, right. So let me try and move it up a bit. Okay, all right, and let me correct here. Is the return self dot front is none. All right, we're done with is empty. So now we are looking for the peak. We define it. Def peak self return self dot front data dot data. Right, return self dot front data if self dot front else none. All right, so return self dot front data if self dot front else none. Right, now let's get on to the implementation of the practical example using the how BLINKIT store implements it. All right, so we create a class online grocery store, online grocery store, online grocery store, online grocery store. All right, so now we begin to define so that we can start calling. So we need def init, we pass self. Right. So now we say self dot order q is q is equals to, now we're calling the function that we created, q. All right, now we need another one for placing the order, so we create another one for placing the order, f place order, and pass self and order. Right, we pass self and order. Now the self dot order q and q order, so we are adding the order to the queue. So when the customer places the order, so that it can be placed, so self dot order q dot, calling the enqueue function, enqueue. Now we are enqueuing the order. Right, so now we need a prompt to show that the order has been placed. So we'll say print order placed successfully, Let's just give it an exclamation mark. All right, order placed successfully. So then the order has been placed. All right, so let's move on to the processing of the order. We spoke about the order having to be processed. So we say def process order per self. Okay, per self. All right. Now we say if it's empty, then we see how we can do it. All right. So now we say if not self dot order queue, if not self dot order queue is empty, then what should we do? Is empty, then the order is equals to self dot order queue, order queue. Okay, then now we're dequeuing because we're now processing the order, so we'll call the dequeue function dot dequeue. Dequeue. All right, so now we want to print a statement of saying the order is being processed. So print, let's print processing order, then the type of order that is being processed. So processing order. All right, so that's where we're processing the order, right? Then now we want to execute the else clause. Else print no orders process. So that is for processing the order. So we've seen that if not order is empty, then we start processing the order that we dequeued there. But if it's empty, that is the else clause, then we say that no orders to process. All right, so I think we're done here. Now let's see it being implemented. So let's call this class, let's give it a name. So since we said it's BLINKIT, so let's call it BLINKIT is equals to online grocery store. All right, BLINKIT is equals to online grocery store. Right, now we want to work on calling it. Let's move it a bit up. All right, all right. So let's work on creating the order. So when customer places the order, say BLINKIT dot place order, we call the place order function place order, and let's call it order one, order one. All right, so let's copy that and then we paste it there. Then order two, order three. All right, so that's for placing the order. We are done with placement of the order. Now we move on to processing of the order. And then we say BLINKIT dot process order. So this will process order 1. Okay, so let's copy that so that we process order 2. So this time when it's being called, it will process order 2, and then again when it's being called, it will process order 3. So we've placed 3 orders there. So when we call it the next time, it will process no orders to process since it will be empty, right? So that's it there for processing the order. So we have seen how we can how it is implemented. The queue data structure is implemented in the BLINKIT online grocery store. So that would be it for now. That's the code snippet. All right, so let's run the code and we see it implemented. Okay, so since we see the code runs, so order placed successfully. So we have 3 times because we placed the order 3 times, and now it's saying processing order is processing it in the principle of FIFO, that is first in. So the first order that we placed was order 1, the second order was order 2, the third one order 3. So you see it's processing it in that order, in that same order, the FIFO. And then it says processing order 3, then after that says no orders to process, because now there is now nothing from the queue to DQ. So the queue is now empty, so no more customer, no order to process. All right, guys, so that's it. I hope this was educational enough for you. So we spoke about implementing queue data structure in the BLINKIT app, in the BLINKIT store, how it is implemented, and we said we'll be using Python. So I hope it was educative enough for you. So that's it from me. See ya.